500 meters beneath Antarctica, where sunlight has never reached, something is alive. Amphipods drifting in total darkness, cut off for thousands of years. The ice here can be nearly 5 kilometers thick. From above, it looks empty, but it isn't. Beneath the surface are uphill, flowing rivers, lakes larger than cities, active volcanoes in million-year-old air, all locked inside Earth's largest freshwater reserve. And now the world's most powerful nations are racing to control it. China is building new year-round stations. Russia is running seismic surveys in contested territory. Antarctica is protected by an international treaty that bans mining and territorial claims. In 2048, that protection can be reviewed. And when it is, presence becomes power. So what is under the ice that is worth this much effort? What are they actually looking for? This is new nature, and we spent weeks pulling together the latest research from glaciologists, geophysicists, and ice core scientists. Antarctica is far more interesting and far more valuable than it looks from above. To see what nations are really chasing, we have to go under the ice. But first, let's zoom out. Antarctica is the 5th largest continent on Earth, larger than the United States and Mexico combined. It holds 70% of the planet's fresh water locked inside an ice sheet that is thick enough to bury the Alps. It's the coldest, driest, and windiest place on the planet. Temperatures drop to minus 90 degrees Celsius. Winds can exceed 200 miles per hour. In winter, parts of the continent don't see the sun for months at a time. And yet life exists here from the surface to the ocean and deep beneath the ice. So let's go down. Antarctica is a library, an ice library. Snow falls in Antarctica year after year and compacts under its own weight. Each layer is a year like tree rings. As the snow compresses, air gets trapped between the grains. Tiny bubbles of atmosphere sealed in time. These rods are ice cores. Scientists drill down and pull up long cylinders of frozen history. Trapped inside are tiny bubbles of ancient air. The deeper the core, the further back in time. This is one of the oldest continuous ice cores ever recovered. Drilled from nearly 3 kilometers down, it contains air that's about 1.2 million years old. If it warms, that record is lost forever. This is how we know what Earth's atmosphere was like long before modern humans existed. The ice preserves carbon dioxide levels, methane, volcanic ash, and temperature signals. A complete atmospheric archive. It records when the Sahara was green and when mammoths walked the Earth, when carbon dioxide levels were half of what they are today. The ice doesn't forget, but this is still just the top layer. Before we go deeper, look at what happens to snow once it hits the surface. Most of Antarctica is covered in bright reflective snow, but in some places, powerful winds strip that snow away, exposing something unexpected: fields of blue ice. This ice began as ordinary snowfall, compressed until air bubbles were forced out. With no fresh snow on top, light penetrates deeper and the ice absorbs reds and yellows, leaving it glowing blue. In some regions, blue ice reveals ice that's hundreds of thousands of years old. Elsewhere on the surface, the opposite happens. Snow keeps falling year after year. It piles up, compresses, and buries whatever lies beneath it. And then there's this. Mount Erebus, the most southern active volcano. Hot volcanic gases escape from vents on its slopes, and where those gases meet the ice, they carve warm caves. Inside those caves, scientists have found mosses, algae, and DNA sequences that don't match anything we've seen before. Life finding a way in the least likely place. But the strangest thing near the surface isn't alive. In 1979, Air New Zealand Flight 901 crashed into Mount Erebus, killing all 257 people on board. The terrain was unstable. The ice is constantly moving. Full recovery was never possible. Snow and ice quickly buried much of the wreckage. Parts of the aircraft and possibly human remains are still likely entombed beneath the ice. The cold can preserve the past and hold it perfectly still. And as we go deeper into the ice, you'll start to realize Antarctica is much more than just ice and snow. It also has heat, history, and it's hiding things we're not supposed to find. We're about 1,000 feet down now, and this is where Antarctica stops behaving the way people expect. Most people think of Antarctica as one giant block of melting ice. In reality, it's doing two different things at once. In West Antarctica, ice is thinning fast. Glaciers are accelerating toward the ocean. Ice shelves are breaking apart. Some of the fastest ice loss on Earth is happening here. But East Antarctica tells a different story. It's colder, thicker, and in some regions, snowfall has actually added ice, at least for now. Satellite measurements show that despite these gains in the east, Antarctica as a whole has been losing ice for decades. But the continent isn't responding as one system. That's the paradox. And it's why this layer matters. If we don't understand what's happening here in this compressed transition zone inside the ice, we can't understand what comes next. So, we keep going down. You're more than a kilometer down now. The pressure here is extreme. Between the ice and the bedrock below, water is moving. Beneath Antarctica, thousands of rivers and lakes form a connected drainage system. Some of these subglacial lakes hold volumes of water comparable to major U.S. reservoirs. When they drain, it happens fast. In some events, billions of liters of water are released over just a few days, comparable to a large fraction of a lake, like Lake Erie, moving underground, unseen beneath the ice. That water can travel hundreds of kilometers across the continent. As it redistributes below, the ice above responds. The surface lifts and settles by meters as pressure shifts underneath, like weight moving across a frozen shell. We've barely touched this world directly. If you add up every place humans have physically reached beneath the ice, it covers about the size of a basketball court. So instead of digging, we fly. Helicopters sweep low over the ice carrying massive electromagnetic sensors, with huge loops suspended beneath them. Systems like Skydom send signals down through ice and rock, revealing what's frozen, what's liquid, and what's moving below. We're, in a way, echolocating a hidden continent. And occasionally, this hidden system reaches the surface. This deep red stain spills from Taylor Glacier, streaking the ice like an open wound. Scientists call it blood falls. When explorers first saw it in 1911, no one could explain it. Algae was suspected, but algae needs sunlight. And this water comes from deep inside the ice. If you look closely, you'll see the water comes out clear. This is ancient briny water, more than twice as salty as the ocean, which keeps it liquid even at -5 degrees Celsius. It's been sealed beneath roughly 400 meters of ice for millions of years. Dissolved iron reacts with oxygen, oxidizing on contact and staining the ice red. Blood falls gives us a glimpse into what these hidden rivers transport beneath Antarctica: iron, organic carbon, and nutrients. There are thousands of subglacial outflows like this across Antarctica. Most never reach the surface. When that nutrient-rich meltwater enters the ocean, it fuels phytoplankton which support krill and everything above them. Everything is connected. The system begins beneath the ice and ends with the largest animals in the ocean. Blue whales, the largest animals to ever exist on Earth. In the 20th century, we almost wiped them out. Between 1904 and 1967, more than 360,000 whales were killed in Antarctic waters alone. Blue whale populations collapsed by 97%. They're recovering, but honestly, there's still a problem. We don't understand them well enough yet: where they breed, how they migrate, what conditions they need to survive in a rapidly changing ocean. And, researching animals this large in a place this remote takes resources most people never see. That's why I became a Planet Wild member. Planet Wild is a community that funds one concrete nature protection mission every month. Think of it as crowdfunding for nature. What I like about it is that it's not abstract. You don't just hear about problems, you see the work being done. Every mission is documented and published on YouTube within a few weeks. I joined because it's one of the few ways I've seen where you can actually follow nature conservation work from start to finish. One of the missions I supported focused on blue whale research. Planet Wild funded drone-based monitoring that let scientists study blue whales without disturbing them and made the resulting data openly available. For me, that really fits this story. The Antarctic ecosystem only works if we understand it well enough to protect it. If you want to support this kind of work, you can join Planet Wild too. You'll start having an impact as a member right away. And as a thank you, I'm covering the first month for the first 100 people who sign up using the link below. Scan the QR code or click the link in the description to become a member now. And if you want to